Can you see my screen? Can you hear me? Just
Yes, sir.
all right. I can start.
Yes, sir.
All right. So hopefully, my part one of my presentation gave you a good idea about what sustainability is, what resiliency is. So now the question is, what can I do? Walk the talk. I just don't want to keep talking, but I want to do something related to sustainability and resiliency in you know in designs, and I want to apply it. So let's look into this one. Okay. Um, the first thing, a lot of people are familiar with this LEED rating system, leadership in energy and environmental design, right? For green buildings. So all structural engineers should be familiar with this. Architects are familiar with this, and there are a lot of geotechnical components, environmental components, water resources components in it. So they need to be combined. So basically, you have different credits, um, and then you rate them, and then based on the score, you get either platinum, gold, silver, whatever, right? So this is has been there for a long time. It's the lead started with the U.S. Green Building Council, but now different countries have their own systems. India has India a lead system. I recommend you to look at that one, and we should be teaching our students about designing the buildings green. As I mentioned in the past, we didn't have any lead and other things, so that's why the old buildings, are not green buildings. Now we are paying the price for that. We are trying to change the windows, change the electricity, energy, and air circulation, all those things, and even the appearance. So the old buildings are now being retrofitted. It's very, very difficult, and you can do only so much limited. Whereas new buildings, you're starting from the scratch, and you thought about making buildings green. From the beginning itself, you incorporate all the features, and they come out to be really good. So these are the two buildings that I'm showing you. There are many other buildings that came up very recently in Chicago. They're all like a green building. Um, so that's how you incorporate sustainability in terms of the selection of the materials, the energy source and ventilation, or and not only, mostly this lead considers only the environmental impacts, right? So that's why these are called green buildings. But sustainability is more than environmental. Remember when I said sustainability is a triple bottom line: environmental, economic, and social. So if you just consider only environmental aspects, that's called environmental sustainability, but not it's like a holistic sustainability, right? So when you say green buildings, they are mainly looking at the environmental aspects. You need to look at economic aspects and social aspects. Economic doesn't mean that just the direct costs. You have indirect costs and benefits, and then the social aspects. People who living there, people in the community, surrounding community, and all those things. But the lead system, as you saw, that one is only for buildings, and the system has been there for many years, and a lot of buildings are built based on that, and considered to be green. But what about other types of infrastructure other than buildings? Okay, when I talk about other types of civil infrastructure, you may be talking about maybe the things related to the energy sector, or water sector, waste sector, transport sector, landscape sector, information. For example, roads. If I have bridges, highways, right? And for example, if I have solid waste management, or in the water, let's say water treatment or wastewater treatment. So how do I check, whether those projects are sustainable or not, right? So lead is only applied for buildings. But if I have other types of civil infrastructure, Okay, for example, airport. Let's say I'm building an airport or roadway or bridge. I'm looking at a bridge, roadway bridge or railway bridge. How can I say whether that is sustainable or not, right? So there is a gap in terms of having a rating system. So Envision is a new rating system that is developed. If you are interested in it, you should look into this rating system. And this can be applied to, this is recommended to be applied to any other civil infrastructure other than the buildings. And similar to LEED, it is a rating system. So you have a lot of these credits, and based on how you are addressing in your project, you give the points, and then you add up the points all together, and depending upon the total score, you get the rating. Okay, so this Envision is the one that is recommended by ASCE. It has 64 sustainability and resilience indicators. So they categorize, even in LEED also they categorize under different groups, and in the Envision also they categorize under these 5 groups: quality of life, leadership, resource allocation, natural world, and climate and resiliency. So this last one you see, that's all the kind of dealing with resilience, and the first 4 are more on like a sustainability aspects, right? So you go under each one is subdivided into subsections, and you have credits for each. There are credits, and then you go through each one and then look at it, right? And you assign the score, and so this can be applied to any project that you're working on. And it's if you are interested in this field, um, try to get more information about this Envision. As I mentioned, that textbook I mentioned, there's one chapter that talks about this one, so that may be a starting point. But what you do is, consider each of these points and see whether that is applicable to your project. If it is not applicable, what can you do in your project to gain that credit? For example, so let's say well-being. In this, for example, let's just look at a minimize noise and vibration. Let's say that's one of the considerations. So let's say you're building some project right next to a source of noise or vibration. Are you doing any mitigation techniques? Are you implementing some mitigation? So that going through these rating points, credits, sometimes you say, I don't know anything what to do, I need some guidance. So these rating tools will provide that guidance. Go through this each credit and understand what it means, and see how you can incorporate those kind of sustainability features in your project. So this is almost like the roadmap, right? If you consider as many as you can, then it becomes more sustainable. All right. So if you have any questions, we can discuss those things in our discussion section. But so this is being applied. This is, for example, for stormwater and management, flood control. In Chicago, we have this huge underground tunnels where we send the flood water during the rain event, and then after that we it goes into the river reservoirs, and then we pump it back after rain stops, and then we treat it and dispose. So, but if you apply this rating system, this may not come to be sustainable option, because you look at how much material that is needed, how much energy is needed, and even then, with the expected climate impacts, this may not be even sufficient. So now, as a result of that, you see the right side, the top left, top and bottom figures. We are going into this as I said, nature-based solutions, right? Green roofs. A lot of buildings. If you just take a picture from the top, aerial picture, and you see many buildings have a green roof. I mean, they absorb the water, and not create a lot of runoff. Also, they have other beneficial effects in terms of the heating and cooling. And then these bioswales like this one, before we had this one, the water would run off and flood all the streets. but having these kind of biospheres and permeable pavements, the water gets infiltrated, so you don't have a lot of surface runoff. So instead of collecting the water, storing it, and treating and disposing it, which is the conventional approach now, instead of that, why don't we go into these nature-based solutions where we allow the water to infiltrate into the ground and then not create that storm water and not have to deal with the issues, right? So you can apply to these projects and then look at it. Now, when you apply the projects, sometimes confusion comes up. Hey, yeah, I'm working on a small project. How can I apply the sustainability? You need to think about sustainability at different scales. Okay, it could be at a global scale, like the countries are coming up with some agreements on curtailing the greenhouse gases, like that. Um, the global agreements that you see. The national scale, for example, India could come up with their energy plan. That's going to be a whole country-wide application. A regional scale, it could be just a watershed area, small region. Business or institutional scale, for example, eco industrial park, or like a university. If you think about the university or campus, college campus, that's the whole thing as an entity. Maybe you can look at the sustainability of your campus rather than one building or one small project. Or the technology scale, maybe just looking at the project that you work on. So on day-to-day basis, if not any of these things, you're working on a project. So you should be able to apply in your day-to-day practice. If you're a consultant or practitioner, or we should be teaching our students, hey, I'm designing this bridge, but let's say look at the sustainability evaluation of it, if this is sustainable bridge or not. Or you can do this kind of assessments on small scale projects. So these sustainability assessments can be done at different scales, global scale to very small project component level scale. So the question is, how do we do it? Especially you have this global scale. You have a UN and national scales, states, regional scale. So those are like a large scale things. But when I want to apply to small scale, technological scale that I do on day-to-day basis, how do I apply, right? So think about the functional definition of sustainability, right? This is the triple bottom line: environmental, economic, social. This is the triple bottom line. We need to consider this one for sustainability. Now let us get into the details. How do I consider this triple bottom line? Okay, I just not showing this graph and consider these things, but how do I go specifically doing this one? To do this one, we need to have indicators for environmental. What are the things that we want to consider in environmental? Okay, what are the things that we want to consider in social? What are the things we want to consider in economic? That you don't have like a universal list, standard list for that you can use everywhere. These are project specific. Given the project, you identify what are the environmental issues. So those are become indicators. But indicators are okay, but what we are looking for is kind of a quantifying the sustainability, incorporating sustainability. We need to select the indicators that we can quantify, metrics, right? So for example, environmental greenhouse gases is my indicator. So I should be able to represent those greenhouse gases by a numerical term, and then I should have tool to calculate it. So we need to think about these indicators for environmental, indicator for economic, indicator for social, and they all should have. Let's not select anything that cannot be represented by a numerical number, and then we need to have tools to calculate this. So that's the way we can do it. Let's go into little bit details about each of these these pillars, triple bottom lines, and look at it. So let's say on the environmental sustainability, just the first thing, first, looking at environmental. So what are the indicators that we can have? Energy. How much energy is needed for this project? That can be calculated, right? Carbon footprint or greenhouse gas emissions. So that can be calculated. Smog, acidification, carcinogens, non-carcinogens, eutrophication. So these are all the environmental indicators. Okay, they can have metrics. and they can be calculated. How can they be calculated? There are like this is where sustainability assessment tools come into picture. So you need to keep an eye open, and there are some tools. Specifically, let's say you are working on a particular project, and there could be a tool developed to calculate the environmental indicators. Okay, for example, SAFE is one that I use extensively for assessing the contaminated sites. If you don't have any specific tool, then LCA, life cycle assessment, is kind of a very general methodology that can be applied to any project that you have. Okay, so I would suggest you to look at if there is any specific project, that a specific tool that is developed for the types of project that you're working on, or you go to the LCA if you don't have that option. So LCA is a very powerful tool to calculate the environmental impacts. And this has a standard also. This is ISO 14040 is the standard. And basically it involves considering the different life cycle stages of a project. As I mentioned before, raw material acquisition, manufacturing, operation, use, maintenance, recycle, waste management. So you have considered that one. For each phase, what are the raw materials? What are the energy that you're using? Okay, and then you're getting the product that you wanted anyway. Okay, but in the process you're going to have this atmospheric emissions, waterborne waste, and solid waste. So these are the environmental impacts that we're going to calculate. So this is kind of a systematic compilation and evaluation of inputs and then outputs, and in the outputs that you have is the potential environmental impacts. Okay, so this is nothing but a database where you give for each life cycle stage of your project, what are the raw materials, what are the energy, those it, and then you're getting the product. Let's say if I'm manufacturing, if I'm constructing a road and I need some materials, what are the materials that I need, and then manufacturing of the materials, construction, and all those different stages that you can consider. And then for each stage, you need to give only the raw materials that you need and energy that you need. Energy could be given in terms of what kind of construction vehicles that you're using it, and the duration, type of construction vehicle and the duration, or how much fuel you're going to consume by operating a machine. So those okay, and if you can input those things, you're going to get this environmental impacts. And as I said, this is the very standardized method, ISO 14040. Everybody follows this one. And this has these 4 steps: goal and scope definition, and then the life cycle inventory analysis. Basically, this is the most important aspect of this analysis, is having a database of impacts, inputs and impacts. So basically what they do is they go to let's say if I'm looking at impacts of concrete manufacturing, so they go to a concrete manufacturing place and they collect all the data, what are the inputs and then what are the emissions outputs, and then they put it into this Excel spreadsheet. So it's nothing but the database of actual information collected from the projects. And if you don't have actual information, sometimes they do the modeling and then generate that data and put it in that. And then third step is the life cycle impact assessment. So you have you have input, everything, output you have, and you can look at the output, but that's not very easy to understand. So there is impact assessments. So, based on the outputs, what are the impacts, the real impacts. Let's say if I am having a global warming, so from all the steps that you have in the project, where are the greenhouse gases? You add all of them together and you get a carbon footprint or global warming effect. Similarly, you can look at combine all the impacts that cause certain carcinogens, for example, or eutrophication or acidification. So those things can be assessed here. I'll show you an example of that one. Then once you have the results, you can interpret. I have arrows going back and forth. This is not like a linear process. Every step you need to look at, do I have data? Do I have the result? Do they make sense? Do I need to refine the scope? So you need to go back and forth in this steps. So then let's look at the second part of our triple bottom line, is the economic sustainability. So the first part, direct economic costs, right? That's what we teach our students in engineering, cost estimate. But what we are talking about economic sustainability is a lot of other things. What are the economic benefits? You calculate the construction cost of a building, but once you build it, okay, are you going to use it for some business? And if that is a business, how much tax revenue you are generating, how much of employment you are generating, those benefits you need to consider, right? And indirect economic costs and benefits, and then social cost of carbon, if you have emissions, what is the cost of that, employment opportunities and human capital, induced economic costs and benefits, project lifespan and flexibility. So you can come up with this economic impact indicators, and you should be able to calculate in terms of the dollar amounts, or in terms of the monetary terms, what those impacts are. So everything has to be able to calculate it in terms of the monetary terms. And this is where civil engineers are not good at it, even geotechnical engineers are not good at it. So this is where we need some help from economists, so people who work in economics department, or we need that. So metrics, as I said, some developed, and then tools. There's life cycle cost analysis and cost benefit analysis. There are some tools that are used not in civil engineering, not in geotech, in other fields, but we need to learn those things and apply to our field. The third one is the societal, social sustainability, the third bottom line. Now, here is the challenge. How is your project is going to benefit the society, and then how do we quantify that one? That's like a really a big question to answer, right? So you need to define, okay, what are the indicators that can be even calculated. For example, population growth rate, student graduation rate, homeless households, drinking water supply. So I listed some of these things here, but you need to identify based on the project. You need to identify the project. You need to identify who are the people who is going to be immediately impacted by the project, who are the people indirectly going to be impacted by the project, and community around that, how it's going to be impacted, how the community's environment is going to be impacted, how the community's economic situation is going to be impacted based on the project that you do. So these are the things that you need to consider. But unfortunately, engineers in general, they don't deal with any social issues. They don't have much interaction with the social scientists. Even in our university, we have a excellent expertise on social sciences, but there's not much interaction between engineers and social scientists. Now, some time ago, National Science Foundation, they wanted to give funding to engineers only if they have a social scientist as a research partner, because these days everybody considering the societal benefits is extremely important in any project that you do. So like that, we are being forced to work with the social scientists, and with time, hopefully we will develop some expertise in this in these aspects relevant to our projects. But it's important to look out people who have the expertise in this area, and then ask them to help us. Okay, so we have this situation here, and I wanted to do some research and quantifying the sustainability, and we didn't have any tool for assessing the social sustainability. So I developed a tool in 2013 called Social Sustainability Evaluation Matrix, SSEM. So again, in the textbook it's there, but also you can find more information about this one. So in this one, what I did is I categorized the social impact, social indicators, as how an individual is going to be affected, how the community is going to be affected, how the economic situation is affected, how the environmental situation is affected. So I created a Excel spreadsheet, and you can download that one from my website. And if anybody wants that tool, I can later on email you just a simple toolbar, simple Excel spreadsheet, and you have all these indicators, right? And those indicators have to be changed depending upon the project. And then you have to do surveys and scale and rate them, at the rate of 1 to 3 or 1 to 5, whatever you want to do it, and then use that survey data to quantify the social impact. So there is no, mathematical way to calculate these social indicators, but there's, you need to really going to the public and doing the surveys and getting that information. And then, we have those triple bottom line aspects, and those triple bottom line aspects have to be considered at every life cycle stage. Okay, so you need to consider all the lives, otherwise you're not getting the true sustainability. If I'm, civil engineers mostly think about, okay, designing it, they think, materials are going to magically appear onto the site, and then you construct it and walk away, and there's some maintenance later on. You don't care about what happens at the end of the life, right? So, but in the true sustainability assessments, you really need to consider all the life cycle stages, and each life cycle stage you need to apply the triple bottom line for each life cycle. So manufacturing of the materials, what are the environmental, economic, social? During construction, what are these triple bottom line impacts? And during the maintenance, what are the impacts? At the end. So if you consider these impacts, triple bottom line impacts at each life cycle stage, and then you add them together, then you get the overall sustainability. Again, it sounds so comprehensive. How do we really do it? Okay, so I want to show you some examples of how it can be done. So this, we're talking about triple bottom line, we're talking about environmental, economic, social. So in environmental, these are the indicators that we can use. Okay, and it's all up to you which ones you want to use it. So you need to come up with these indicators that can be calculated, and then these are the economic costs and benefits, and here are the social indicators. So all of them should be rationally selected depending upon the project, and then we should be able to calculate the metrics. This is where the challenge is. Okay, come up with the indicator that can be calculated, and then you need to have tools to calculate these things. So then what you do is you apply that triple bottom line, you calculate the triple bottom line aspects for each of your life cycle stages: raw material acquisition, material manufacturing, transportation, construction, operation, maintenance, reuse. So, and then, so once you have that one, for, you can categorize all the environmental impacts for each life cycle stage. You have the big list of those, and economic, and then social. You have all this list. So when you done with this kind of calculation of all these parameters or indicators, you have a big spreadsheet, with all these different indicators and have values. And they will be all over. For some indicators they are very good, some indicators they look negative. So if I'm looking at a project, or if I'm comparing two different options, so you won't see consistently one option having all positive impacts, right? So then the decision is easy. Okay, in every respect this project is better, so go with it. That doesn't happen. Sometimes the greenhouse gases are good for this case, but the carcinogens are more for the same case. So you will see that conflicting results for different indicators. So how do we make a decision based on this multi parameters that you have? So that's where we use the multi criteria decision analysis, and then we calculate the sustainability index. Once you have that sustainability index, you can make a judgment on how sustainable is your design is, or if you have alternative designs, then you can look at which one is better, or you can do the optimization. So where are the negative impacts coming from? So you don't have to look for things that don't make much difference. Maybe you can identify, hey, this equipment that I'm using is causing a lot of problems. So then you can think about using a different equipment, right? Or maybe it comes out like, oh, this particular material that I'm using, that's causing a lot of negative impacts. Maybe then that gives you an idea about substituting that material with some other green material. So this sustainability assessment is not, in the end goal is not like calculating this fine number, sustainability index. It's all about the process. In the process, learning and revising it. That's the process is more important than the specific numbers you get at the end. So this is what we do. We apply the multi-criteria decision analysis. You have all the indicators, economic and social, and you can apply the weighing factors. And then remember, all these indicators, the economic indicators are in dollar numbers. Environmental indicators, depending upon which environmental indicator you looking at it, they will have different units, right? Social indicators, they don't have units, they are ratings. So you are looking at apples and oranges. How can we combine them together, right? So that's where this normalization comes into. This value function, you use it, and then you normalize all those values from 0 to 1, and then you apply weighing factors, and then you have a criteria level, how much criteria, environmental criteria, economic criteria, social criteria, and the requirement criteria. So basically, just a spreadsheet. You can set it up and to calculate the sustainability index. These weighing factors, as I said, it's a preference. So how much value you give them. That sometimes you give equal weightage to everything, but sometimes you can do this analytical hierarchy process, getting the feedback from the stakeholders and see which ones are considered more important than the other ones, and based on that you can decide the weighing factors. I recommend, there is more to it. I will be happy to answer any questions that you have in the future, if you want to pursue or learn about this methodology. So but I recommend you to read this article and then get back to me, if you have any questions on this. Okay, so we apply this methodology for different types of projects. Now I'm going to show you some geotech projects and geoenvironmental projects. For example, let's say you are building a multi-story building, and this is actually the project that we did. It's a high-rise building in the city of Chicago, and because of the high load and poor soil conditions near the surface, you need to have a deep foundation. So this is the soil profile of typical Chicago. So you have a sandy fill material, clay, and that goes down here. So when you have deep foundations, we teach in foundation design for our students all the options that they have for deep foundations. One is the pile group, other one is the caisson. In Chicago, we call it caisson, but in the literature, it's mostly drill shafts, right? Those drill shafts, the big concrete in situ piles. So we teach that one. I teach a foundation analysis and design course, and we teach this one. I give the profile to the students and give them structural load. I ask them, design the pile groups or caissons. They will do that one. And the pile group that can, according to one design, is 14 piles. Outside diameter is 20 inch, and the thickness is this one. These are pipe piles. And then the drill shaft is 3 feet diameter shaft, straight shaft. And then you at the bottom you have a bell shape that's very commonly used in Chicago. So you have a bell shape at the bottom, and its bottom diameter is 8 feet, and it's a 4 feet deep. So you go 3 feet. This is like a 55 feet deep foundation. So you go up to 50 feet with 3 feet diameter, and then after that you bell it, and basically you enlarge it, and then the bottom diameter is 8 feet. So basically you are having a larger area for end bearing. So that's where a lot of buildings in Chicago are constructed with this drill shaft foundation. So then we do the environmental sustainability assessment. Remember all the environmental indicators and calculating them. So we use this LCA, life cycle assessment, can be done using the software called SEMA Pro. And then economic sustainability assessment, we calculate the direct cost and social cost of carbon. And then social sustainability assessment, we did an online survey. And then we calculated all those values, and I use that Qualix framework. And then at the end, we get the sustainability index value. So when you do the sustainability index value for the piles, this is less than 0.2. Whereas caisson, this is 0.8. So it's really, really high. And in here, there are other factors, but you don't see those things inside here. So this considers all the noise and vibrations, all the material impacts and all those things compared to both of them. So you see that in this particular case, caisson comes out to be a more sustainable option based on, again, the geologic conditions based on uh, the project specific conditions. That's why cautioned here a different outcome may be obtained in other geological conditions and other project specific conditions. So if you want to have a more details about this project, I would recommend you to read this paper and you will find more information. So if you have any questions on this one, I will be able to answer. So this is how you can apply. See, it's not about talking, but it's about applying it. Okay, these both piles and caissons are applicable. Okay, so both of them can do the job that you wanted, like a technical performance. But out of these, which one to use? From applying the sustainability as a additional criteria, right? So now if you use the caissons, hey, you are contributing to the sustainability. All right. Now let's move to a little bit of a geo-environmental side. So this is the lake. The sediments here are contaminated, and people wanted to use this lake for swimming. So obviously, you don't want people to swim in the contaminated lake, right? So they wanted to remediate that sediments. So to remediate the sediments, you have these options. So this is the sediments, soils, groundwater. These are all like I like them as a geo-environmental topics, because those who have understanding of geotechnical engineering, if you add chemistry, you will be able to do good job on this one. So these are the different options. This is a kind of a, monitor natural attenuation is not doing anything. Laterally, naturally, let the microbes degrade the contamination. But unfortunately, that takes a long time. So that's not a feasible option. Other option is dredging and taking out and disposing it at another landfill, which is one option. And conventional capping is putting something on the top of the sediment so that contamination does not come from the sediment into the water. Water is always clean. Other one is modified cap with reactive core mat. Basically, you put a reactive material in a cap, and then as the contamination tries to come from the sediment into the water, you have a reaction taking place and you have treatment happens. Conventional capping, basically, you are not allowing it to come into the water, whereas in the modified capping, you are not only not allowing as it comes, you are treating it. So we applied the same thing: environmental sustainability, economic sustainability, and social sustainability. These are the triple bottom line aspects. How do you do that one? Okay, so these are the you have indicators and you have tools. You have those things calculated. I'm not presenting a lot of those details because I recommend you to read these papers, and they will have very detailed information on how this sustainability assessment was done, what are the indicators, how they were calculated, what are those numbers, and then economic sustainability, how they were calculated, what are those numbers, and social sustainability, what are the specific indicators that were decided for this project, and how the survey was done, what are the ratings. So you can find all that details here. Okay. And then based on those following that Qualix protocol framework, you can calculate the sustainability index. See this one, sustainability index. So higher the sustainability index, better it is. So this modified capping comes out to be the best option. Okay. So this is how the systematically you can do the analysis and then find out the most sustainable option to use it. Whether you use the sustainable option at the end, that really depends upon a lot of other factors which are beyond beyond the technical people, because sometimes some stakeholders want particular solution, then they try to push it for various reasons. So then finally that may be the option that people use. But as with your strong ethics, okay, you should be able to tell people that this is the best way to assess the situation from your point of view. This is the most sustainable option. That's what you would recommend it. Okay. And this is kind of a nice framework, and you see me applying the same kind of framework for different projects, and not only in geotechnical and geoenvironmental projects. Let's say you dealing with bridge design, or you're dealing with roadway pavement design, or you can think about the projects in different civil engineering field and apply the same framework. Okay, so this is another groundwater remediation situation. This is a contamination site. Groundwater was contaminated, and you don't want people to drink the contaminated groundwater, so you need to remediate it. And based on all the details about the site and everything, we came up with these three options. And then again, we do the environmental sustainability, economic sustainability, social sustainability. See that now there's kind of a one framework that can be applied at the project level. And if I apply that one, this method has given me the high number, and the second best is this one, third is this one. So obviously, when you have very low number compared to the other one, forget about that option, because that's obviously not a good sustainable option. So you need to choose the one which is the highest option. And then again, I'm putting I hope you can see the reference at the bottom, that gives you the details about the entire detailed methodology. I have a lot of different types of case studies that I have done similarly. For, wide range of, so retaining walls, and subgrade improvement, ground improvement. All those things are done using this framework. So I hope you can teach this one and ask the students to do some projects on this one. That's probably the best way to learn is to teach, and best way to learn even more is working with the students. The students are very, very talented these days. Just give them the problem, and let them come up with the solutions. They're very smart. So what we need to be thinking about is sustainability, that triple bottom line aspects, and the resiliency. Also, you need to think about survival and rapid recovery. Okay, so the framework that we developed before, as I've explained through applications, it did not consider resiliency. So then what we did is we created a new framework which considers this triple bottom line is sustainability, right? And the resiliency is the climate resiliency. So we integrated, triple bottom line and resiliency together, and then created this framework. Okay, so this is the reference to this framework. Again, this framework gives you a systematic roadmap in terms of how you need to proceed. If you have a project, it's as simple as, let's say, designing a bridge, designing a column, designing a beam, designing a foundation, designing a retaining wall system. It could be that low level project component, or you could be looking at whole building, or you could be looking at a whole campus, everything, all the structures, parks, everything in there. So this framework is scalable. Okay, so if I want to do a project and I want to design sustainable and resilient project, so this is the framework. I go to step by step. First thing is, these are the four phases. Phase one is about finding out the most resilient option. Okay, so first thing is you need to look at the resiliency, and then second and third phase is same as qualics that I mentioned, looking at the environmental, economic, and social, and then integrating the resiliency as one of the indicators in all the things that we see. When you have a environmental, social, economic, and the criteria, you have a resilience is included in this one. So as I told you, this environmental, social, and economic, you have, in addition to that, we have to have a resilience. So following this procedure, now we can look at it. For example, that case study where lake sediment remediation alternatives, the conventional capping is this, and the modified capping is this. Conventional capping is, as I said, like you put layers of these materials so that the contamination does not go in. And in modified capping, you have sediment, but you have a reactive mat. Here you put a material that can react with the contamination. As the contamination goes up to this reactive mat, it cleans up, so you have a clean water exchange with the water column. And the dredging and disposal is other option. So I mentioned this one before, but using this revised framework that consider the resiliency, now you can first based on the phase one, you can calculate the resilience index. So dredging and disposal concept to be the most resilient option. And you have a conventional capping, modified capping, they don't come out to be that option. But as I said, we should not be looking at only the resilience, right? We need to balance resilience and sustainability, so that when I apply this combined resilience and sustainability framework, I get sustainability resilience index. It's called RSI. And then you look at this one, the modified capping comes out to be the best. So it's not just the resilience, it's you need to resilience of all the triple bottom line aspects, environmental, economic, and social, how they are going to be robust if you have this extreme climate impacts that is happening. So this integration should be done. Don't look at the sustainability, don't look at the resiliency separately. So you need to combine them together and aim for sustainable resilient index. Again, I recommend all of you to look at this book. It's very easy to read. Hopefully you can recommend your library to get it. And then if you have any questions on anything, I will be happy to answer. So this is my last slide. Just the take home messages. You have been hearing me for almost 2 hours. I want you to take some lessons with you. The first thing is think about climate change, okay? And don't think that climate change is not civil engineering. So climate change impacts are felt everywhere, and then as engineers we need to be designing the resilient systems. So but it's designing resilient systems is not easy. So we need to adopt this adaptive management methodology, because the climate impacts are not well known, or not cannot be predicted easily, cannot be predicted accurately. But in the long run, we should not be having the climate problems. So the climate mitigation is important. That can be happen only by controlling the greenhouse gases. And then when you control them, uh, then eventually you don't have to deal with resiliency issues. But in the broader context, you should look at the sustainability. So in the climate mitigation, control of greenhouse gases is considered as one of the broader environmental impacts. But you have other environmental impacts, the pollution, the acidification, all those things, and then economic and social issues that you need to consider. So our goal should be, the sustainability should be incorporated in resilient options that we are going to select for addressing the climate impacts. So the most important thing that you should take away is, let's not keep talking about how important is sustainability and resiliency. We should be putting into practice. We need to be doing things in our projects that reflect the sustainability and resiliency. So for that one, we need to use tools, right? Assessment tools, quantifying tools. Let it be. It could be LEED. For buildings. It could be Envision. It could be some focused assessment protocols like what I proposed, Equalizer. So that will give you a structured approach. As I always was mentioning, uh, don't worry too much about the numbers. It is the process, because otherwise you would not have considered those aspects in your design. So in a typical design, you go with your own way of following the steps and you do it. But now you are forced to think about other things that you were never thought about it, but you don't know what to consider, right? These frameworks will help you. Okay, they have this points to consider. So then when you think about considering those points, then you think in a broader context, and your solution will be much, much better than conventional design. And the last point is, okay, in order to be sustainable and resilient, we have to use nature provided solutions as much as possible. Okay, nature based systems are always, based on my experience, are going to be sustainable and resilient. So look at alternative options to what you are doing. What are the nature-based options that you have that can be incorporated into your, don't think about right away, using some steel structure, a concrete structure, or some other fancy material that you want to use for your construction. See, is there any other nature-based materials that can be used for your projects? So with that one, I know I took a lot of your time, but other resource for you to get more background on sustainability and resiliency, and also geoenvironmental engineering, is to go to this YouTube channel. I would highly recommend you to go. There is a playlist with sustainability and resiliency. I think you will learn more by viewing those videos, and you can even share those videos with your students. But more than that, you may have a lot of other online resources to use to enrich your knowledge and your students' knowledge. This is my contact information. So feel free to contact me. My email address is here, kreddy@uic.edu. I'm in Twitter, Facebook, and LinkedIn. More importantly, I would recommend you to go to these websites. Just click on these websites one time, at least go into the publications section. The publication section is here, and see, all my, publications there. And you should be able to download. There is a PDF for links to any paper that you are interested in. Even the papers that I mentioned, they should be there, and you can download it and see it, and use those references in your teaching, or even student assignments. Whatever way you can use the resources, I will be happy about it. And you can always feel free to contact me if any additional help is needed. So with that one, I think just I'm going to stop here. But there are a lot of examples that I have, I can share with you. But you know, anytime, just I want to just close up with this one example here. So a lot of people do this soil stabilization, right? They use the lime, right? So the question is, should I compact more or should I use more lime? Which one is more sustainable? I can get the same results, if I add more lime, or if I use less lime and compact it more, right? So you can do that research on this one. So should I use dense, less? For example, this case I'm going to show you. So if I dense more, use less lime, or compact less but use more lime. There are consequences in terms of the sustainability, right? So here I'm using the more material. Here less compaction means I'm not using the equipment that much, so my energy consumption is low. They all give me the same results. So if I have this density, high density, and the low lime content, I will get the same strength. So if you do the assessment on that one, you will get interesting results. So here, it shows that uh, the uh, low lime content and high compaction is the sustainable option. So you can make all these different kind of decisions, because production of the lime is highly energy intense and carbon intense. So if you can use less lime, having a little bit more compaction, even though you are spending a little bit more energy on that compaction, but net effect would be much more sustainable. So that's kind of the point that I wanted to mention here. So there are many things like that can be decided based on this environmental sustainability. In the sustainability, the triple bottom line sustainability, right? Environmental, economic, and social. If you are not comfortable doing the economic and social, do at least environmental sustainability. Environmental sustainability is more established than other options, other assessment methods. You can, at least you can do whatever that you can. So at least to do the environmental sustainability, and see options for what you're doing. All right, so with that one, I'm going to stop here. I think we're going to take a break, and then we can come back and have a brief discussion session. Are you there?
Yes, thank you, sir, for the wonderful presentation. The presentation dealt with so many aspects, such as ecological footprint versus human development index, global climate change, and the challenge and sustainability of safe environment, 2030 UN Sustainable Development Goals, importance of resilient engineering for facing the challenges, triple bottom line with the environmental, social, and economic factors, key drives for future change, and sustainable development for accreditation of engineering students and the institution as well, followed by the impact indicators focused on a from a lot of dimensions and perspectives, and the very important triple bottom line and the framework for sustainability index with more sophisticated softwares for assessing the environment in a sustainable manner. Thank you, sir, for the effective presentation. I hope all the participants will take key indicators seriously in their research development. Thank you, sir.
I know we're supposed to end
Supposed to end.
Yes,
early, but
participants, if you have any quick questions, can ask our distinguished speaker.
you want to take a
You want to
break,
take a
5 minutes
five
break,
minutes
and then
break,
come
and then
back
come
and
back
have a
and have a
question
question
discussion?
discussion?
Sir, I think it is time for us to post the feedback link for the participants.
Okay.
Okay.
Since it
Yeah,
is
we.
time bound, uh, we are
So I
obliged
can,
to.
I can, I can, yeah, I can
I
stay
can stay
late.
late.
I can
I
stay
can
now,
stay
and
now,
then
and then
I can
I
answer
can
any
So
answer any
questions that you
questions that
meanwhile,
have.
you have.
I can also request participants to have quick questions in the chat box also, sir.
Yeah.
Yeah.
So there is a question from Balameshwari AP Civil. May I know about the scope of geothermal energy?
Yeah, geothermal energy is used extensively. So there are two different types of geothermal, right? So deep geothermal, and that is possible only in certain areas. But shallow geothermal, is used extensively everywhere in the U.S. So as I showed you, one of our buildings in on the campus, we have a geothermal heating and cooling, and a lot of houses. Even a couple of my friends, in their backyard, they have these geothermal wells, and their houses are heated and cooled with the geothermal. So geothermal has become very common, and they seem to work very well. So in terms of the research, what you can do in that is kind of a bit questionable. Um, I remember, I had a student working on our geothermal project on our campus. We tried to monitor the temperature of the water being circulated, and inflow and outflow temperature, and we didn't see much change for over 2 year period that we monitored. So there was not a big issue on that one. But now, what the biggest cost with geothermal is drilling the holes, and you know that's the biggest cost. So now, there are a lot of geotech people, they're proposing to use foundation itself. Let's say you have a concrete foundation, and run the pipes through that foundation. It's called energy foundations, um, and not have to have these separate wells to be drilled, for the space constraints or for cost constraints. But the problem is that when you use only foundations, you may not be able to um, meet your energy demand. That's the first question. And the second question is, a lot of people are worried about the performance of your foundation itself when you put these geothermal tubes in there. So try to look at the literature that is there. People are doing a lot of research, but you need to tailor your research, um, I always like to do research that would be useful to practice. Just don't do the research for the sake of writing a paper. Uh, at the end, I mean, when you do good research that has a practical applicability, you will definitely get good papers out of it. But the focus of your research should be on how you can potentially use that one to solve a local problem that you have. I hope I answered the question, but you can find more information on. A lot of research is being done on geothermal, so there's a lot of literature you can look at it. And if you need more information, let me know.
Thank you, sir, for the insight on the query. Now it is for time for the vote of thanks. I thank our guest of the day, Professor Krishna R. Reddy from Professor, University of Illinois, Chicago, for giving a wonderful presentation on addressing sustainability in geotechnical and geoenvironmental engineering. A special thanks to our beloved Secretary, Dr. K.S. Babai, MSEC, for supporting this FDP in every manner from the proposal till the present date and for the future endeavors. And I also thank our AICTE ATAL FDP coordinator, Dr. R. Arivagan sir, for coordinating this wonderful FDP. And I wish all the participants, who includes our faculty from all over India and the research scholars, for gaining more such sessions in the future and make use of this wonderful FDP. Thank you, sir. Thank you, ma'am. Thank you, everyone, for attending the day one of the online mode ATAL FDP. Thank you.
Thank you. Yeah, thanks
Thank you, sir.
everyone.
Thank you, sir.
Thank
Thank
you.
you, sir.
Good night.
Thank you, Reddy sir. Thank you.
Yeah, thank you so much. Good night. Late for you.
Yes, sir. Yes, sir.
All right.
Yes, sir. We can leave,
Bye.
sir.
Okay. All right.
Thank you, sir. Now, participants, the feedback link is posted in the chat box. Make use of the link before leaving the meeting.